Week 13, Section 2, Swyk 2. We're going to jump to the unit circle, teach you something about that before we come back to these next few problems. Actually, I'm going to teach you a lot about the unit circle, so hang on to your hats here. You'll notice that I divided the circle on the left into 30-degree chunks. Those are each worth pi over 6 radians. So we're going to count around the circle in pi over 6 jumps. So the next jump, would be 2 pi over 6. Now you and I both know that reduces, but I'm not going to reduce it right now because I want you to see what's going on here. Then we have 3 pi over 6. Why isn't there writing a 3? We know that reduces, but I'm not going to reduce it right now. Then we have 4 pi over 6. Same thing. 5 pi over 6. That one does not reduce. 6 pi over 6. That one does reduce. 7 pi over 6. 8 pi over 6. 9. What am I doing? Seriously. Can't even count by my own measuring system. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And then lastly, we get right back to the beginning, 12 pi over 6, which is 2 pi, which we know is one complete revolution going all the way around. Those are specific locations that we will need to get more comfortable with. Yes, I know you will need a lot of practice to know where 5 pi over 6 is. You know, for instance, I should have, you know what I should have done here? I should have backed up. This is the first time you've ever seen the unit circle. Everybody should know this. 0 is right here on the far right side of what we call the unit circle. Why do we call it a unit circle? Because the radius is a 1. Okay. Positive rotations move in this direction. Negative rotations move in that direction. So some of the angles we were doing in the first Swyk were positive, some of them were negative. But, 0 heads in the, or positive heads in the counterclockwise motion, negative heads in the clockwise motion. But everybody starts out at 0 on the far right side, right at this location. Okay, that dot on the outside edge is what we would call 0. Okay, as you can tell, the unit circle I have drawn was missing some of the middle values, so to speak. So let's count around the circle in those increments. You can see that I have pi over 4, or 45 degrees, listed out. It's a positive rotation. Well, then at the top we have 2 pi over 4. Now, you and I both know that reduces to pi over 2. Pi over 2, that's 90 degrees, right? Well, that makes sense because if 1 pi is equal to 180, over here, that's equal to 180 degrees. Then if I cut that in half, that would be 90 degrees. Makes sense. Okay, if that's 2 pi over 4 at the top, then this would be 3 pi over 4. And this would be 4 pi over 4. And as I said, you know that some of these reduce, just like this one over here reduces, right? 6 pi over 6, that's the same thing as pi. Then you've got 5 pi over 4. At the bottom, 6 pi over 4. Now, 6 pi over 4 and 9 pi over 6, identical. They're both 3 pi over 2. Absolutely identical, which is 270 degrees from one of our previous examples. Well, I think that was a negative. Okay, then we would have 7 pi over 4 And lastly, right back to the beginning, we have 8 pi over 4, which we know that that is 2 pi. Now, if you count around the circle in pi over 6 jumps or pi over 4 jumps, you find the most important places on the unit circle to us. I know there's lots of points on the unit circle. For things like pi over 8 or 32 degrees. But these are the specific points that we deal with the most. Probably because we deal with 30, 60, 90 right triangles and 45, 45, 90 right triangles. That's probably why we deal with it the most. Now, some things to consider. Take a look at, I'm just reminding you that SOHCAHTOA is your sine, your cosine, and your tangent, right? All right. So, pun intended. If I wanted the cosine, I would do the adjacent side divided by the hypotenuse. Remember I taught you that you could classify that as opposite hypotenuse, and that leaves you with one side, the adjacent side. But the adjacent side over the hypotenuse is x divided by 1. We know that that simplifies to x. If I do sine, opposite over hypotenuse, I get y over 1, which equals y. If I do tangent, which is opposite over adjacent, that would be y over x. When have I ever heard of y over x before? Wait a second, that's the slope of the line. Yes, it is. Rise over the run. For those of you who don't remember the rise over the run. No, I didn't misspell that. Y's go on top. Just trying to help you remember. Okay, so the connection we're trying to make here is that cosine goes with x and sine goes with y and tangent goes with slope. That's what I really need you to understand. Now, there are some really important values on the unit circle. And those important values start out with, at least the x's and the y's, start out with 1, 2, 3, 4. Okay, you obviously know those go in order from least to greatest. And if I take the square root of these, guess what? They stay in order. Now, they are more compressed, that's true. And then if I divide them by 2, they are also shrunk down even more, but they're still in the same order. Now, if you want to simplify them, you get 1/2. This one does not simplify, although it is approximately 0.707 if you needed a decimal. I mean, we know 1/2 is 0.5. What about radical 3 over 2? No, that doesn't simplify. And that is 0.866. Sorry, the decimal point got a little out of control there. And then at the last, that reduces to 1. Now, I have taken the liberty to mark the x's. You can see that this one is positive 1/2. You can see that the one on the far right is positive 1. The two values in the middle are the two that we've just written down. You've got your radical 2 over 2, and then you've got your radical 3 over 2. They go in order for the x's and the y's. So 1/2. Radical 2 over 2, radical 3 over 2, and lastly at the top 1. We'll talk about tangents later, but I know this is a longer video, but I really needed you to understand this. Before you can even get into understanding the trig values, you've got to see a visual of how the circle works, how you can count around the circle in increments of pi over 6 or pi over 4. where these numbers, 1/2, radical 2 over 2, radical 3 over 2, and 1 are coming from, so that if I randomly give you this spot right here and say, oh, that's 2 pi over 3, and I ask you, what's the cosine? Well, if you know that cosine is the x value, it's not too hard to tell me that it's negative 1/2. If I ask you for the sine, it's not too hard for you to tell me radical 3 over 2, positive radical 3 over 2. It's the x and the y value. And you can look at the scale. There's only 4 numbers. They go in order. Now, did I say negative 1/2 for the x value? I hope I did. They also go in the negative direction. So negative 1/2 is here, negative radical 2 over 2, negative radical 3 over 2, and negative 1. Those kind of questions will get asked in the Swyk, so let me zoom onto that and show you those. So here we are, we found 5 pi over 4. We counted around the circle. We start out with 0, 1, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So we're down in quadrant 3. You can see that I've drawn lines to the x and the y. And the x and y are both negative down there. And we can see based on the number and the counting, it's not negative 1/2. It's definitely not negative 1. So it's got to be one of those in the middle. And since it's the one right next to negative 1/2, it has to be negative radical 2 over 2. Okay, what about the sine? Sine's the y value. It's definitely not negative 1/2. It's not all the way down at the bottom, negative 1. And it does end up being negative radical 2 over 2. Man, I wish I had a nap. Bet you've heard that before. Okay, 7 pi over 4, you can see I found it on the circle, counting 1, 2, 3, 4, 5, 6, 7 pi over 4 jumps. And the x value is a positive radical 2 over 2. The y value is a negative radical 2 over 2. So, positive radical 2 over 2, negative radical 2 over 2. How do you draw angles in standard position? So, this, going back to degree, is going to be easier. So you've got that 45-degree angle, and you're coming down. Or I should say, you're at 0, and you're coming down 45. That is letter choice A, headed in the negative direction. That's halfway in the middle of quadrant 1, because at the bottom would be negative 90. As you can see in letter B, positive 45 would be choice C, and positive 90 would be choice D. 240-degree angle, well, that's going to be choice B. I've written out the other angle measurements. They look approximate, right? Negative 150, positive 150, negative 240. Now, the term coterminal, sorry that this video is so long. The term coterminal means it stops in the same place. You know, you can keep going around a circle forever and ever and ever, in forward or backward. It doesn't matter. So, if you land in the same place on the circle, we say that those two angle measurements are coterminal, same stopping point. So, find a positive angle less than 360 that is coterminal with the given angle. 530, well, I could subtract 360. And that'll take me from 530 degrees down to 170 degrees. I think I did that right. Take away 300, that'd be 230. Take away 60, 170. That sounds right. Question 12. Oops. Find the measure of an angle between 0 and 360, coterminal. So all I had to do is, once again, subtract 90 and subtract 360. to get into the correct range or the correct value. How about finding a positive angle less than 360? So I started off with negative 190, so I decided to add 360. And when I did that, I found 170 degrees. Keep in mind, folks, all we're doing, you're looking at a circle, and you're at negative 190. Negative 190 is like over here, because you're going in this motion. And we want the positive angle. So hopefully that red angle makes sense that it's positive 170. 14, same thing, find a positive angle less than 360. So you can tell I took the negative 320 and I added 360 to find out that it was 40 degrees. That's enough for that, Swyk. Yeah, because I definitely went over my time that time.